No problem, no problem.
We will start just right now.
Yeah.
Okay.
几分钟露下脸儿。We miss Li Penchen. Yeah.
Buenos días. Continuando con el ciclo de conferencias con motivo del 70 aniversario del Observatorio Astronómico Félix Aguilar. Hoy tenemos el gusto de presentar al doctor Jinzeng Li. El doctor Li representa a los observatorios astronómicos nacionales de China y a la Academia de Ciencias de China. El profesor Jinzeng Li tiene numerosos trabajos. Sus campos de investigación son sobre estrellas y formación de planetas, clústeres, formación de clústeres, estudio de estrellas jóvenes, y es el principal investigador del proyecto CAR, radiotelescopio chino-argentino, que actualmente se está instalando en el Observatorio Astronómico Félix Aguilar. Hoy, en el día de hoy, nos va a compartir una conferencia sobre el tema de las colaboraciones astronómicas entre China y Argentina en las 3 décadas pasadas y perspectivas futuras. Bueno, lo dejamos con el doctor Li en su charla.
Should I start now?
Yes, please.
Yeah. Thanks to Carlos Francilli, my good friend, for the introduction. And as it's the year for the 70th anniversary of OAFA, starting from 1953. So I'd like to take this chance to show my warm congratulations to all of you here, and also to OAFA for the 70th anniversary. So we can see the card site below, which is looks very nice, very beautiful. Okay, firstly, I think I would like to go take some 3 minutes to show you the.
Lee, sorry, we don't see the presentation here.
Oh, really? Sorry. Let me see.
Did you open it?
Let me see. Did you see it now?
Okay, yes.
Okay. Yeah. I would like to, let me see, how should I start? Okay, I would like to show you first the card video so that you have an impression of what a card is and how it looks like. You see the central axis, and it's already there at the real site. And also the tracks, which is now being seamless welded at the hosting site. Now you can see the solid panels, which has a very high precision of less than 0.08 millimeter per piece. Cart represents the most advanced technology of the manufacture of radio telescopes in China. And all 8 bands were designed. So we have the capability to observe with up to 8 bands. And as I will introduce later, we will have firstly the SX dual band receivers, and later the Q band maybe. We almost got to the point for building the Q band receiver. This is the simulation of the SX band receiver, the dual band receivers with X in the internal inside the X band receiver, which is smaller. It's hopeful for us to see cart erected there on site within something like 10 months from now. That means it's hopeful for us to see cart there in June next year. And then it will enter the testing phase. And okay, yes. Then it's the 1 meter fully mobile model of cart. It's just newly manufactured in a factory. Which will be sent to Argentina. And we can show them to the young kids and the public in the outreach activities. So you can hear the noise for the running, for the operation of the cart model with the diameter 1 meter. It's purely man-made. Again, perhaps. It has just the same appearance of cart. It's a copy of a cart with just a smaller diameter. Ooh, let me see what's happening. You can see the a whole day video record of the on-site monitoring of the cloud site. It looks beautiful, and you can see the sign set and also the set of the moon following the sign. Then we see another one. You can see the moving sky full of clouds. Okay, maybe again, because it's not good to. Okay, now I get back to the PowerPoint. Okay, I will start the lecture, which is named the overview of the Joint Chart project. First, a historical review of the China-Argentina astronomical collaborations, the initiation and the key progress made with CART, both in China and in Argentina, for the manufacturing in China, and also the site search, the flattening, and the construction of the concrete foundation, and so on. And also scientific objectives of the CART in the testing phase and also in the operation phase. And working bands and the plan for the manufacture of the receivers in the upcoming years, starting from the testing phase. And also synergies with ALMA, YAMA, and AGO about Argentina, and maybe also possible collaborations with ALMA as a single panel, along with YAMA, and also future perspectives of the collaboration. Some of the slides here are in Chinese because because I have not so much time to change that into English. The background of the work of the Joint CART project, why we are trying to build a CART, a 40-meter radio telescope in the southern hemisphere or in the southern part of the globe. Mainly because the galactic center, the Magellanic clouds, and also many of the pulsars of the galaxy can only be observed in the southern sky of the globe, and also some famous star-forming regions. And also for the application of astronomy, the establishment and maintenance of the international reference frame, terrestrial reference frame, and also the international celestial reference frame are all based on VLBI observations, and which should be CART will be able to contribute a lot in this direction. And also the establishment of the epoch of giant planets of the solar system. And also we can contribute to deep space explorations, and also the monitoring of the Earth's orientation parameters. As just mentioned, we can have some synergies with both AGO and YAMA of Argentina. These two are major programs of Argentina. And also we, as a unit of VLBI investigations, we can collaborate with the European network, VLBI network, and also VLBA of USA, and the antennas of Australia and South Africa in the operation phase. You can see that in the northern part of the of the globe, we can only observe just a part of the sky and the Milky Way. So if we want to observe the central galactic center, the magnetic clouds, and some of the major star-forming regions in the southern part of the sky, we have to go to, for example, South America. This is a short video to explain, to give you an expression on the sky coverage of observatories or observational facilities in north and the southern part of the globe. So we can, for the facilities in China, for example, we can only observe just a part of the sky. So we need to also go to the south part of the hemisphere so that we can observe the whole sky, all the celestial objects that we want to observe. So this is the location. You can see the location of OAFA and also Ciclo Observatory, where we will build CART, or we are building CART. So we had actually a very long history of astronomical collaboration with OAFA and UNSJ. The collaboration was initiated in 1989, so more than 3 decades passed. Starting from PA2, the Photo Astro Lab in 1990, and later we built the satellite laser ranging system in 2006. And in 2011, we have the first GPS built at OAFA, and later, starting from late 2010, the Joint CART project was initiated, and it has been lasting for so many years till now. And construction now at Ciclo. And also we built a GPS system in Argentina for the assessment of the beetle system. So which is also helpful and has been collecting data, helpful data. So then I will talk a little about the main objectives of the Joint CART project. We know that there are very few radio telescopes in the southern hemisphere. So once built, CART will be the largest single dish and also the largest VLBI unit in South America. It would be an important VLBI unit in collaboration with VLBA, the European VLBI network, and other VLBI antennas in Australia and South Africa. As a single dish, it can contribute greatly to the observations of radio sources in especially the southern hemisphere or the southern sky. And also, we can contribute a lot to the investigations of astronomy, geodesy, and also maybe deep space explorations. For example, the lunar, the explorations of minor planets. It's a Chinese program. Will come into the atmosphere from the southern sky in 2027. At that time, I believe CART will be there operating, and I suppose we will have a chance to contribute also to the Chinese program on the exploration of minor planets in space. And also, as I have mentioned, we will have important synergies with Yama, Argo, and also maybe ALMA in the future. So this is the distribution of the main astronomical observatories on this globe. We can see that most or a major part of the observatories, and many of them are optical observatories, are located on the north part of the globe. So we know that the best optical and infrared, near-infrared observatories are Hawaii, and some others are located in Chile, in a very narrow lane along the ocean line. Sure that there are also other nice observatories in Argentina, for example, Argentina, and some others in Australia and South Africa. I don't think there are many good sites in Brazil. So that's why we go to Argentina for building CART and also the satellite ranging system. With CART acting as a VLBI unit, we will be able to collaborate with European countries for the investigations of astrophysical objects in space, and also with collaboration with VLBA and the antennas in China, and also maybe Australia and also South Africa. So anyway, CART will act both as a single dish for carrying out regional surveys, for example, for star-forming regions, and also as a VLBI unit, we will surely contribute a lot to the international collaborations with any other countries and any other antennas working in centimeter and even millimeter. So this is a true simulation of CART, 3D simulation of CART. So CART is actually a complex or a platform for observations and research. It's a platform nurturing many high-tech branches of research and investigations, including the manufacture and invention of the cryogenic receivers and sort of technologies like this. This is the status of CART when it's being manufactured in China many years ago. So we can see the primary dish, the primary reflector in the factory. Marcelo has been there taking a look by himself, and it's a pity that Ricardo and Anna and Carlos did not go there, did not have a chance to be there. So everything is ready actually in 2013, and it's ready for delivery by the end of 2015. You can see the frames, the manufacture of the solid panel in the factory, and the spotting structure and a control panel. This one is obsoleted, so has to be replaced now because it's too old to work. You can see the spotting structure in Shanxi province, and also what we call the central body for spotting the primary reflector. And you can see the big rulers shining light there, and also the solid panels for CART. It's a simulation of the cabin for hosting the cryogenic receivers up to 8 working bands, and also the X-ray X-band polarizer, and also that for the S-band. You can see the simulation for the X-band SX dual-band receiver. This is also the simulation of the X and S-band cryogenic receiver. And this is the original time scale for the implementation of the CART project. However, as we all know, there's many unexpected delays in the past 13 or more years. And we have just experienced also the 3 years of COVID-19, which shut down everything globally. So the manufacture of CART system was actually accomplished in 2013, and it has been waiting for its delivery within the past 10 years. So now 13 years passed, and at least the control panels, including the personal the PCs are and the control panel are too old and obsolete. So they have to be rebuilt. So that's why we have to pay extra money to NOAC for covering the long-term storage more than 10 years, and also the rebuilding parts like the control panels, and also the increase for the transportation, especially after the COVID-19 period. Everything is much more expensive, especially the sea transportation. For any cargo delivered by the sea or by air, the fares for transportation is actually 3 or more times more expensive. Now everything is the first set of the CART parts have already been delivered to the Chesco side for the on-site construction, as we all know, and the expected date of the erection is something like June next year. So you can see the key agreements we signed within the past 10 years, starting from the four parties MOU signed by President Bai Chunli in 2011. I still remember that I accompanied the president to visit OAFA and UNSJ and Buenos Aires at that time, and we are very happy. But it's 12 years ago. And later we experienced too much within the past 10 years. And in 2015, we finally signed the four parties agreement with between NOAC and GONISAT, UNSJ, and the San Juan government of Argentina. So we can see the key progress in each year. In 2012, we did the site search for at many candidate sites. We did the RF testing in the field, in Anna, Carlos, and Ricardo, all of us, and also Ernai, and all of us contributed a lot. We fight in the fields for more than 40 days. Anyway, we get very good results. This is a picture at Delagasto when we are doing these camps are built by Ricardo, Carlos, and Anna, and Ernai, I think. So we can see the nice Milky Way in the southern sky, and also the Magellan clouds, which is very beautiful. And these are the results for the RF testing. And we can see below, there are some interference below 1.5 gigahertz, but above 3 gigahertz, there is basically no interference. Any interference would come from the space or from the satellites, actually. So we can see the visit in 2013, Minister Lino, who visited and also NOAC. Sure that he visited first most and the headquarters of the CAS, and then I invited him to pay a visit to the headquarters of NOAC. At that time, we had a very nice time together, and we have dinner together, and we are all very happy. In 2014, I went to Minsit to do the defend on the potential grant from Minsit. So finally, we got $1.5 million from Minsit as a grant for CART, for the construction of the CART Foundation, especially. And in 2015, we signed the four parties agreement by Roberto and the director of UNSJ, the director general, Professor Yan Jun of NOAC, and also Hyoha, the San Juan governor, or our best friends. And in 2016, we would appreciate the ministers, the foreign ministers of both China and Argentina. They meet and push forward the joint CART project so that we have a good chance to move on after we have been encountering so many hard times. In 2017, the Chinese ambassador in Argentina visited the hosting site, and we built the cornerstone, and we had a celebration at the Chesco. All of us are so happy because we did make progress, and we are starting very soon the flattening. In 2017, the presidents of China and Argentina, Macri, met in China, and for the first time, the joint CART project was included in the joint declaration of both countries. So we had the strength to move on. In early 2018, the $1.5 million from Minsit was delivered by Macri, who is the president at that time. So we appreciate very much the grant from Minsit, which helped us a lot. And within the past 2 years, we actually went a very hard way. We realized the top design in the end, but we did that in the bottom up way. So we start from CAS most we had the support of the ministers, the San Juan government, the governor, and also the foreign ministers of both countries. At the end, we get the support of the presidents of both China and Argentina. And CART was included in the joint declaration between China and Argentina for twice. One in 2017, another in 2019. Now we can see the progress made after we get the grant from MinSit, and also the delivery of the $2 million from China. So we had also sure that also we have got the financial support from the San Juan government, which has been contributing so much. So we had the chance to improve the road and also the bridge on the way up to Chasco. And we did the flattening, and we start to build a platform for hosting CART. We can see the starting point, which are, you can see the hills and the initial road on the platform. And then we start the on-site flattening. Thanks to everyone here from OAFA for all your kind of efforts and contributions within the past 13 years. So we did a lot of work, and you see the cornerstone there, which we set as the ceremony. And you can see the flattening activities and the progress made. And we dig firstly a square, the round hole, and later it is a square hole. This is the initial design from Astoli. So we thank also Astoli for their hard work and for their nice performance for the construction of the CART Foundation. Because in early 2020, when we have just accomplished the concrete foundation, you know that we had experienced a 6.8 grade earthquake just 50 kilometers away from Chasco, with a depth of just 10 kilometers. So this is very good. This is something like a test for the CART Foundation. I feel very impressive that everything is okay. So thanks goes to also Astoli for their good performance. So this is what we have with the concrete foundation and the CART platform. Later on, you can see the first truck from New Yi was delivered. The mountain behind the truck is called the Becker Turtle. So this is the delivery of the very first truck from New Yi, from the factory of New Yi. Marcelo Segura has ever been there. So these are among the first trucks to be delivered from the factory. These are the solid panels, actually, and you can see the frames. So you can imagine that we have a series of trucks moving to the harbor at Tianjin city. You can see the car parts at the harbor. You can see the hoist at the harbor, and also the ship. And everything is there, well aligned at the port. So you can see the ceremony at Chasco site, and also the activities, the celebration, and the arriving of the car parts. And then it is what you can see now at the construction site. So this is the foundation that we have, and we will take about something like 10 to 12 months to have CART erected on site in Argentina. These are the specifications of CART. So the primary mirror has a diameter of 40 meters, and all are solid panels, so it can work up to a frequency wavelength of 7 millimeters. So we have all 8 bands designed. So it can work up to something like 50 gigahertz. Each solid panel has a precision of less than 0.008 millimeter. So it's a very high precision. And that's why I've been talking that I've been stating that CART represents the most advanced technology of the manufacturer of radio telescopes in China or antennas in China. So the pointing accuracy can be better than 3.5 arcsecond. And we will surely try to build a Q-band cryogenic receiver and to try to carry out some of the regional surveys by ourselves. So these are the specifications of the receiving systems, the cryogenic receivers. I won't have time to go into details, I think. Then I will go briefly through the scientific objectives of CART. Firstly, as a single dish, we can carry out some regional surveys of the star-forming regions, and also the galactic center, the magnetic clouds as nearby neighbors of our galaxy, and also the famous supernova remnants in the southern sky, and also for pulsar timing. We know that FAST as the biggest, the largest single dish on this globe. We are discovering up to now something like 1,000 new pulsars. So we had a chance to do the timing of the pulsars. It's hard for a 40-meter to discover new pulsars, but what we can do is timing, is the monitoring of the timing of pulsars. So also we have a chance to investigate the giant planets and also the comets of the solar system. And also we will have time for TOO, the target of opportunity to do follow-up observations of the gamma ray and then the gravitational waves, and also for other transient objects such as follow-up observations of fast radio bursts. As a very long baseline interferometer, as a unit, we can carry out international astrophysical investigations and also co-investigations in fields of astronomy, astrometry, and also geodesy. And also we can possibly contribute to deep space explorations. As a single dish, the first thing we can do is to carry out molecular line surveys. We can investigate the physical features of the emission measures, such as the temperature, the dynamic information, and things like that, and also density. And it can be, some of the molecular lines can serve as good tracers of star formation and their early evolution. And we have chances to discover new molecular emission lines. And also we have a chance to study and then to investigate oxygen, organic molecular molecules in space, which is tightly related to the initiation of organic systems. So we had a chance to search for large organic molecules in space. And also we can investigate sulfur and silicon chain molecules, which is very the advanced research nowadays. And we can carry out investigations of infrared dark clouds with ammonia and NH2+ as tracers of ARDCs, and investigate the physical properties of massive star-forming regions. We mentioned already the search for the largest possible molecular clouds only in space. So we may also have some synergies with FAST if possible in the upcoming years. And also we can do all follow-up observations of transient objects in radio stars in space. As the LBI and unit, we can carry out international astronometric and geodetic investigations. Firstly, the establishment and the maintenance of the International Celestial Raster Frame, and also the International Terrestrial Raster Frame, which is the Ricardo and Anna, and also maybe Erna are professionals on this in these fields. And we can surely contribute a lot to these international programs, and also potential contributions to deep space explorations, such as lunar and Mars explorations, and also the explorations of minor planets, as I have just mentioned, which will be landing in 2027 from the southern sky. So we had a chance with CART for contributing a lot to the Chinese program via international collaborations with co-investigations with Argentina colleagues. So also we can observe some other programs, which is also in Chinese here. I'd prefer to go fast through these. So the initial working bands or CART will be the SX dual band cryogenic receivers. And we almost got the grant for the invention of the Q-band receiver, which will go from 33 to 50 gigahertz. So we will have a chance if we got the grant finally, which is hopeful to be granted next year. And if that's the case, we will have a chance to find new organic molecules in space. And some of the synergies with Yama. Here we, as I mentioned, we will try efforts to build first a Q-band receiver so that we can have synergies with Yama. Q-band will be the first receiver, I think, with Yama. And also we can have collaborations with Argo, which is also a co-location system with VLBI, GPS, and also satellite laser ranging system. So we had already had several joint papers with Gloria Dubner of OAFA, and I hope to have more extensive collaborations with OAFA colleagues and some other colleagues from other institutes of Argentina. Then I come to the future perspectives. The establishment of the China-Argentina Science and Technology Center based on the Joint CART project. Actually, we have already realized because a joint agreement between CAS and GONISAT was signed in December 2019 by President Bai before his retirement. And also we'd appreciate to be able to extend our collaborative fields to a much wider scope. And the establishment of the joint research center between NOAC and UNSJ on the institute level for the small science operation and maintenance. And also it would be helpful for us to get the operational funds from both sides. And we needed a continuous support from the Argentina side in the support for manpower for the operation and maintenance fees, and also routine financial grant for operation. We'd like to stress that once CART was built, it will surely become a landmark of the San Juan province, and it will most likely boost the tourism and also especially outreach activities for young students and young kids and kids. As I have shown you at the beginning, and we have already built a 1 meter mobile model, which can be a very good facility for showing the young kids and for teaching the young kids and students, including the bachelor's degree students. I would like to take this chance to show my great appreciations to the San Juan government for their great contributions to the CART project ever since the very beginning, and also all of you here from OAFA and UNSJ for all your kind of support and help and all your kind of efforts, starting from the site search, the RFI testing campaign, the past 10 years, what we have been facing together, the hardest times. And I'm sure that we will have a good chance to have CART built and operate smoothly, and then we will surely have good performance with CART. And I think we will surely have a chance to further strengthen the ties of a scientific collaboration between China and Argentina. So this is finally the calligraphy of President Beck as a memory for all our efforts made within the past 13 years. So as you can see, I'm turning old and I have white hairs, and time is going very rapidly, and I hope to have CART built as soon as possible, and we will enter as soon the testing phase and also the operation phase. Thank you so much.
Okay, thank you very much, Jinzeng.
Yeah, thank you.
Questions here?
Hi, Lee, how are you?
Yeah, fine, thank you. Yeah, yes, Marcelo.
Very nice talk. I have some questions related to the future cooperation, because I don't know if you know, but last week there was a workshop in Jeves, and one astronomer from Argentina represent us there. And basically people there don't know that CART could reach a Q-band, and they are really interested on working together. As you mentioned in your presentation, there are, well, possible collaboration around the globe. But the question is there any, I don't know, mutual agreement or whatever with some of these European observatories?
Not yet. We are, I've ever mentioned to you that we would like to start to initiate some collaborations, and to maybe we try to sign some agreements with the YABS Observatory, and maybe also the Australian institutes or universities, PACS, for example, so that we can carry out collaborative investigations in the future, starting from the testing phase pass. But we actually don't have time or energy to do this yet. So perhaps we can do that as we plan for that, starting from now.
Okay, yeah, that's the point, because I don't know if Carlos mentioned before to you, but OAFA just a month ago, more or less, signed an agreement between Jeves and universities for mutual collaboration in the future. So maybe we can use, that agreement in order to increase the future collaborations.
Yeah, yes, but I appreciate if we can sign an agreement between three parties, including NOAC. That would be good, and maybe also CAS.
Yeah, for sure. Just another question on that also workshop. Everyone asked about the receiver's characteristic, So the question is, well, on phase one, S and X receiver will be the first one. So the point is that receivers are already built or are in the progress, and
it's now being built, because once the cryogenic receivers are built, they will have to the compressor will have to start to work continuously without any stop. So every electric facility has lifetime. So we cannot start earlier. So we have just started we have tuned the design, and within the past few years we actually updated the design several times, and I think we have the best design for the SX cryogenic receivers, because the technology in the invention of cryogenic receivers is also developing fast within the past year, 10 years especially. So we have just started months ago, and it will be ready at the testing phase of CART. Okay.
Yeah, that's the point. If the receiver will be ready, let's say next year, but this time,
sure. It will surely be ready at around the test phase, and people from the factory will be there for mounting the cryogenic receivers at CART on site, And also hopefully we can get a grant for building the Q-band receiver. It would be very nice if we can have a chance to collaborate with the YABS colleagues for the manufacturer of the Q-band receiver. But I think they have less interest to do that because they told me they have not so much time and energy to do that. But I do hope that they can help us to develop the Q-band receiver because they are very successful with the YABS 40 meter. They have discovered a lot organic molecules in space, which is very, very, very good, news now.
Yes, we have yesterday we have another conference that was given by Pablo De Vicente, the JEVES director, and of course he showed us a lot of research on the 40 meter.
Yes.
So okay, thank you very much.
We do have the capability to develop Q-band receivers, but I don't think it's as good as the high tech from the YABS colleagues. So that's why I'm trying to persuade them to collaborate with us to get a better performance. But if they have no interest in the end, we can also have the Q-band receiver developed in China, and I believe we can also have a very good performance.
Yeah. Okay. Question: is possible to share, for example, students or people from here to develop such kind of detectors and so on?
Yeah. Yes, one of the objectives I think for international collaborations is the outreach activities. We have the responsibility to teach together the local kids and students, young students.
Okay. More questions? Okay, I think it's time to leave the meet. Thank you very much, Jinzeng. We very grateful that you share with us in this special anniversary of the observatory. So we hope to see you soon here in San Juan, working at the radio telescope.
Yes, me too.
Okay.
Hope to see you soon. Yeah, bye-bye.
Sure.
Sure.